All right, so before we take a look at the bonus problem, I do want to talk with you about a shortcut that we could take advantage of for any problem like these. So including problem 4 up here. So hang in there because you'll like this shortcut a lot. So one thing we could have done back in problem 4 would have been, so they said a sub 1, a sub 2, a sub 3, a sub 4, a sub 5 was negative 1, 0, 6, 17, 33, like that. And so, and then back in problem 4, we were diagnosing, right? And we were like, okay, your first row of differences isn't constant, so we're not going to have a linear model. Your second row of differences is constant, so you're going to have a quadratic model, right? Well, you could actually use this work for more than just figuring out what kind of model you have. You could actually have, if you wanted, you could use it to kind of like go back and figure out what the zero term would have been. So hang in there, like you're gonna love this, just so you know. So what you could have done is you'd be like, okay, well, I know these are all plus 5s, right? And so you could have kind of gone back. So what would you have to add 5 to get 1? Well, you could just subtract to get back. So negative 4. So hopefully that makes sense. So because if you add 5 to that, you get to the 1. And then that could help you to figure out what the zero term would have been. So basically, in order to go to the right, you'd have to subtract 4. So to go to the left, you'd have to, wait, do I have that right? You'd have to add 4. And so I think that would have been 3. Yeah, that would have been 3. Oh my goodness, that makes so much sense. Okay. Anyway, so that means your zero term would have been 3. Okay. And how could that help? Well, you know how when we did it before, you knew your model would have been some generic quadratic, which we would still know. But knowing the zero term to be 3 really kind of gets you, because like, see, you'd plug 0 in for n. And so it would tell you really quickly that C was 3, as opposed to having to work harder for it. See how hard we had to work for it in the standard method? So it's kind of a nice little trick to go back and figure out what the zero term was. And then that would really save you a ton of time if you think about it, because then we knew a sub 1 was negative 1. And so, and now we already know that C is 3, right? Like C is 3. So that would have sped things up a ton. See, because you're already down to just having 2 unknowns. And so that would simplify out to be, so you could subtract the 3 over, whoops, yeah. So you subtract 3 over. And then you'd only have to use the fact that a sub 2 was 0. Since again, you know that C is 3. And then you could start 3 over. And then instead of having a full system of equations with 3 variables, you very quickly get down to just having 2, and then you could boom, 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 finish it out. And so that's a shortcut for problem 4. And let's see if I can pull it off for the bonus. I do have a tendency to screw up mundane details, but let's see if I can pull this off. Okay. Okay, so for the bonus, let's see. You'd have to add 3, and then add 6, add 10. What is that? Add 14? No, add, oh my goodness, math is hard. 17 plus 15. And then add, how many is that? 21. There we go. Okay, first row of differences, definitely not constant. And so this thing is definitely not a linear model for the nth term. Second row of differences, add 3, add 4, add 5, add 6, still not constant. Second row of differences, not constant, definitely not a quadratic model. So not degree 1, not degree 2, and then this was extra credit because I never really demonstrated it, but I did hint at it a little in that last video. Third row of differences is constant, which means we're going to get a cubic model. So not degree 1, not degree 2, but degree 3. So congratulations if you figured that out. So basically we're looking for a model like that. And then to save time, you could use that zero term move that I demonstrated up there. So we could kind of go back. So we know that you'd have to add 1 to move to the right. So that means you'd have to subtract 1 to move to the left. So then that means that difference would have been plus 2. And then you're going to add 2 to go to the right, so you'd subtract 2 to go to the left. So that would mean adding 1. And then you'd have to add 1 to go to the right, so that means you'd have to subtract 1 to go to the left. So that means that the zero term would have been negative 3. So a sub 0 would have been negative 3. Okay, so using that in this model would have been pretty great, because we would have known that negative 3 would have equaled a times 0 cubed plus b times 0 squared plus c times 0 plus d. And right off the bat, we would have known that d was negative 3. So congratulations if one way or the other you got d to be negative 3. And then we'd know your first term would have been negative 2. And so putting that in, and we can also, I mean, we know d is negative 3, so we can just put that in instead of treating that like a variable. So we'd have a sub n would be, oops, not a sub n. A sub n, if n is 1, would be negative 2. And then, boom. And then d again is negative 3. And then I'm just going to simplify that. So I'm going to add the 3 over and simplify. There we go. So I already have, I'm already down, instead of having 4 unknowns, I have 3. Second term was 1. So that would mean we'd have 1 comes out when you're plugging 2 in for n. Okay, I'm going to add the 3 over. I end up with 4. Simplifying this. So, and then a little note to self, I really want to just multiply both sides by 1/2 to like kind of scale that down a little bit. And so I'll probably do that later. Let's see, a sub 3 was 7. Adding the 3 over and simplifying the right side. Like so. All right, now let's just solve this. Let's see, I'm gonna go for eliminating c's just because the coefficients are the smallest and because you're really easy with row 2 to get kind of like opposites right there. So I think that's what I'll do. So I'm going to do negative 1/2 times row 2. Something I've learned with, I've done a lot of solving systems of equations, which means I've also done a lot of messing them up. One thing I've learned is that it's a lot easier to get things right if you set yourself up to always add equations as opposed to subtracting. So you'll notice I have a tendency to multiply by a negative scalar and then add equations together as opposed to doing subtraction. For some reason, subtraction is just hard. Anyway, so let's multiply through. So we'd have negative 2 equals negative 4a minus 2b minus c. And then we'll add that to row 1 because I'm trying to get the c's to eliminate out. Okay, I'd end up with -1 is equal to -3a minus b. Okay, now I need to eliminate c's again, and I need to wrap in on row 3 here. So I already have -1/2 times row 2 right here. So I'm just going to multiply this, I think, maybe by 3. So let's do that. So I'll just do, let's see, I'll just say times 3 would yield. -6 equals -12a minus 6b minus 3c. And then I'm going to add that to row 3. So I'd have 4 plus 15a plus 3b, it looks like. There we go. All right, so now just between these two equations, I need to eliminate another variable. I'm going to go for b. So I'm going to multiply equation 1 by 3, because then I'd have perfect opposites there. So 3 times equation 1 would give me -3 equals -9a minus 3b, and we're going to add it to equation 2. Right, so it looks like I'm about to get a equaling 1/6. Woo! All right, that sounds like what other people got, so I'm feeling okay about that. Okay, and now let's get b. I personally would back substitute into this equation right here. So let's see, what would we get? -1 equals -3 times a minus b. Well, -3 times 1/6 is -1/2, and so I'm just going to go ahead and like add 1/2 to the other side. So I'd have -1/2 equals -b. So it looks like I'm about to get b equaling +1/2. So now I've got a and b. Now I just need to go and get c, and I really like this spot right here for if I know a and b getting c. So let's do that. So 1 would equal a, which is 1/6, plus b, which is 1/2, plus c. There we go. So let's get a common denominator. Let's get everything over 6. So 1 is 6 over 6. 1/2 is 3 over 6. So we got 4/6 over here. When you add those together, subtract it over, we get 2/6 or 1/3. So C would be 1/3. Boom. Final answer. Let's see. Hopefully I got this right. Your nth term would be, and I'm just going to go back up to original model and then put in the constants now that we know them. So A was 1/6, so you have 1/6 n cubed. B was 1/2, so plus 1/2 n squared. C was 1/3, so you'd have 1/3 times n. And D we found really early to be -3. Oh man. Congratulations if you got it. It was worth, what, 3 points for that bonus problem. So big, big, big congratulations if you got it. And let me know if you have questions. Have a great day, everybody.